Good morning, Ms. Hannah and class of 8-2. Our science project will be on a gear and pulley system. The need for this project was to lift up a 500-gram whale up 15 centimeters and down 10 centimeters by using at least one simple machine.
The first plan we came up with was a lever system. So the sandbag or the whale would be on the one side of the lever, and you would push down with the other side to lift it up and down. And the second plan was using a triple pulley system, each side the dowel through, so that when you pull each side of it, the dowel goes up along with the sandbag attached. The third was we were gonna use a drive worm, which is basically a screw and a wheel and axle slash gear, but it's also called a drive gear system. So the screw will be like a crank to spin the gear, but the gear cannot spin the screw. Only the screw can spin the gear, and that would give us allow the gear to be spun slowly at approximately 20 to 1 ratio, and also give us a high mechanical advantage. So to build it, we just made the square, the frame first, and then two dowels through it, and the gears, and it still spins smoothly and good. And we put the tubing inside to stop it from wiggling, so because the accuracy, and around some of the pulleys too. And we added the legs after that, and the support and these supports, but turns out it was too short, so we don't actually need them. But anyway, and then we made these two frames, pulley frames, with the dowel and the pulley through, and then we added these hooks and that hook, and then this was kind of imbalanced, so we added the jigs wood on there after to kind of make it balanced. And then what we added was these three jigs wood to glue this on, so that when you pull it, it stays on, and only this one moves up and down with the load. We're gonna be demonstrating how to use our system. So when you turn it to the left, it raises the pulley, which is tied onto the load, which also raises the load. So it has so far been raised IDK. When you spin it to the right, it lowers back down. It lowers back down, and see how fast it spins the yellow. Lowers it back down. Tiger lowers it back down. Lower, lower. On the ground. So how it works is when you turn the gear, when you turn the driver gear, it turns the follower gear the opposite way, which is actually tied onto a string. The string that works the pulley. That's connected to pulleys. And these, when you pull it, the string rewinds up, and it pulls this pulley set and pulls it up as with the load that's all tied on there. So the legs don't do anything, these don't do anything, supports don't. Yeah. And now we're gonna demonstrate how fast it takes to lift the weight, the 500-gram wheel right here, up 15 centimeters and lower it back down 5. Almost 15, almost 15, almost 15.
Stop! So now we are going to raise it 15 centimeters and then lower it back down 5 centimeters. Our science project uses a gear system and a pulley system. The formula to find the mechanical advantages of a pulley is input distance over output distance. The formula to find the mechanical advantage of a gear system is follower teeth divided by driver teeth. For the pulley system, our input distance was 64 centimeters and our output distance was 15 centimeters. This was a total mechanical advantage of 4.26. For our gear system, the follower teeth had 60 teeth. The driver had 20 teeth. This equals a mechanical advantage of 3. Adding both together would total a mechanical advantage of 7.26. A strength of our science project, pulley and gear system, is that it has a high mechanical advantage. The mechanical advantage is 7.26.
Another strength is that it carries the load efficiently and far up and down easily, very easily, by just turning the driver gear.
A weakness for our pulley system is that we cannot place it on a flat surface because we made the legs too short, and that the pulley system is lowered and it does not work on a flat surface.
Another weakness is that this frame here, it's kind of unbalanced, so it tilts a bit to the right, and we could have found a bigger gear for the driver gear and a smaller for the follower.
To improve our design, next time we could have made the legs longer so that we could place it on a flat surface and it would be a lot easier, or we could have not had legs at all and just used the two pulley systems and the gear system.
And the hangers.